Okay, good. So, previously, just mute your mute your speaker, please, because it will echo. So, why is echo? I think my voice go through someone. So, or it's better now. Yes. Okay. Okay. So, yeah. Right. Huh? Can you turn the speaker off? Mute it. Last week we you cannot. The microphone is mute, but speaker, can you down the volume? Or you have, yes, you plug the headphone. Okay, okay, no problem. So last week we why? Huh? But your phone, if you connect with your phone, you can do it or not? Okay, so last week we discussed about thermodynamic consistency, right? Why we need thermodynamic consistency? I hear someone again. Mute. Okay. All right. So why do we need thermodynamic consistency? Why do we have to check for thermodynamic consistency first? We arrive at thermodynamic consistency because we discuss about the method to what's it construct activity coefficient model, right? And in order to to construct the activity coefficient model, why I keep you mute, but you turn on your microphone. Muted. Mm? Yes, muted. Okay. So we need VLE data first, right? And then from VLE data, we construct a activity coefficient model. You use Samsung everything. You use everything from Samsung, and you cannot control your device. Okay, that is a problem of technology, you know, when you use it, but you cannot control it. That's a big problem, big issue. Like when you're giving a speech and then Siri try to help you. It disaster. You unmute again. Why? Why you unmute again? Because I keep checking it because the voice is not clear when we record it, and then it will cause problem. Yes, this is mute. And but mute microphone is not thing related to speaker. You connect your headphone. Try to connect your headphone. Next time, don't buy Samsung because you cannot control it. Okay, so anyway, we need thermodynamic consistency. And for thermodynamic consistency, we keep echoing. We use Gibbs Duhem. Why it's automatically turn on microphone? Come on. Why always? I don't have. Okay, so we use Gibbs Duhem equation, right? And what we need is what we have. The first one is point-to-point test. For point-to-point test, we start from Gibbs Duhem equation directly. This equation. I believe that everyone from last week you get back and check the meaning of Gibbs Duhem equation and more fundamental things related to Gibbs Duhem equation. Okay, so the simplest one for thermodynamic consistency is this one, point-to-point test. So from point-to-point test, you see it's actually the Gibbs Duhem equation, right? All you need to do is you should plot between log gamma, right, and x1. Once you have data, and then from that data, you, of course, if you have data only x and y, right, at different temperature, constant pressure, then you calculate gamma. Okay, you know how to calculate gamma, right? And of course, don't worry, we're going to do it today in a class and in our class. And then you take log and then plot between log gamma and x1. Okay, then you can find derivative at each point. Okay, and from derivative and x1 and also derivative of log gamma with x1, multiply it with x2. Each point, of course, must satisfy the Gibbs Duhem equation. Okay, so I have some data here, so I will show you just one moment, and we will work on real data. Looking for the data published this year. Vapor liquid equilibrium. Okay, we look at this data. Just one moment. Okay, check this paper. You see it from the screen, right? Okay, this article published Weber liquid equilibrium, WLE, data of binary mixture of isopropyl alcohol and methyl ethyl ketone with dimethyl sulfoxide. Okay, we have mixture of isopropyl alcohol and methyl ethyl ketone. Okay, so from the abstract, you see it's VLD data. Okay, the first one is isopropyl alcohol plus dimethyl sulfoxide. Okay, when I highlight it, you see my highlight, right? Okay, and the next one is methyl ethyl ketone and dimethyl sulfoxide, dimethyl. Okay, and also ternary mixture. Of course, we focus on binary mixture first. Okay, and what data available here? We have data. Yes, isobaric VLE data. And we have measure VLE data from IPA and MEK, okay, from table 4. This one. You see this table? Okay. So today we're going to play with this data, measure VLE data of IPA and MEK system. Okay. So what is X1 and Y1? One is standing for IPA. Normally we use light component as 1, okay? And of course, heavy component will be 2, okay? So we have X1 and Y1 already in this table, okay? And this data is at constant pressure, okay? 101.3 kilopascal, okay? And what else do we have? We have gamma already. Gamma I have already, calculated. If I believe that you can calculate by yourself if the gamma is not given here. Okay. Anyway, we will calculate gamma by ourselves, and also we will check thermodynamic consistency by ourselves. Okay. So you open maybe Excel. Excel is good. Yes. Oh, you need this file. Do you need this file? Yes. So I will send it to maybe Line group. Hmm? To determine gamma? No, you don't. How to calculate gamma? Hmm? Remember VLE data, VLE model. On the left-hand side, you have YIP, right? Equal. On the right-hand side, you have gamma I, Xi, Pi, right? So gamma I is YIP over Xi, Pi. Right? Okay. And what do you need? What else do you need? You need Pi. P is constant, of course, 101.3 kilopascal, right? But you need Pi. at different temperature. Okay, you need Armstrong equation, right? And it's given in this paper, I think. I think, just check. You have to check. It should be given. Where is Armstrong equation? Here, I think. Yes. Equation number 2, PIS denotes saturated vapor pressure, which is derived from the extended Armstrong model. See? Yeah. Okay, you see it, right? Equation number 2. Okay, so the parameter of C1, C2, C4, C5, C6, C7, or C3 also are given in table 3. Okay, so from table 3, you can access to that data. Mhm. Use you can use Excel or any spreadsheet. At the very first line of that table, table number 4, right? Table number 4. Yes, table number 4. At the first line, first row, x1 is 0, y1 is 0. What does it mean? Pure what? Pure MEK, right? Yes, because the component 1 is IPA, right? What is IPA standing for? What IPA is standing for? It's not beer, huh? Isopropyl alcohol. Okay. Finish. Hmm? Okay, so at the very last line, the temperature is 355.2. That one is the pure IPA, right? Okay. So actually, at this X and Y, you can plot the equilibrium, right? Equilibrium line, right, between X and Y. Do you remember, right? So we will see how it look like. Can you see my Excel? This is how X and Y relate, right? Right, see my screen. Yes. Well, if we plot our reference curve, you see that the reference curve cross the equilibrium curve, right? So we can expect a central for this system. What do you think? Yes or no? Right? Cross the reference curve somewhere, and then at the point where the equilibrium curve cross the reference curve, of course, that point is a central. Okay? And now we're going to calculate gamma. How can we calculate gamma? To calculate gamma, you need PI. P of IPA, saturated vapor pressure of IPA, and also MEK, right? At different temperature, right? So from equation number 2 and table 3, you get the required data. Okay, it's extended Armstrong equation. Now you can do it yourself. Then, in order to calculate gamma, you need P1, okay? And you need P2, right? What is pressure here? The pressure in the unit of K, what is the unit of, yeah, kPa is all right. We check again. I don't know. Okay. So from PO, yeah, we cannot, yeah, we can calculate here also, right? At this temperature, what is P1? This temperature and this temperature. Let me see the formula first. P is in the unit of kPa, right? Kilo Pascal. This one is in the unit of kPa. Okay. And you need C1, C2, C3, C4. Okay. C5 and C6. C7. Okay. C6. Okay, so we pay attention to, before we calculate it, we pay attention to C8 and C9 because C8 and C9 is the boundary, right? It's a lower bound and upper bound that we can use the following expression to calculate the saturated vapor pressure, right? And you see that all, oh, not just one moment. Okay, all the temperature in this equilibrium, in this data, are in this range, right? So we can use this one, okay? EXP of C1 plus C2 over temperature plus C3. Where's our temperature? Temperature is here. Plus C3. Okay. And plus C4 time with temperature plus C5. Oh, no, C5 should be C5. With log of natural log of temperature plus C6 power, no, time with temperature. C6 should be yeah, constant cell, and this is temperature, power to C7. Yes. Hmm? No, this is not correct. The temperature is too high. What's wrong? Which term is wrong? Hmm? Which term is not correct? Check this one first. Without EXP, we get 400 something. e power to this value. What? exp of this value, why it's really high. Which term is not correct?ไม่เหมือนกันครับ มันมีเหรอรอนใน Excel มันมีสูตรเหรอเป็นรอนเลยไม่อาจารย์เอ้ยมันต้องใส่ล็อกเหรอไม่ใช่ใส่ exp เหรอมันต้องสูตรแล้วตรง C ไฟล์อ๋อเนี่ยเหรออืมอืมน่าจะถูกใช่ไหมล็อกเดี๋ยวนะล็อกมันอืมโอเคอืม what is P? P is 101.3, right? Kilopascal. Mm-hmm. So, so how can we calculate gamma? Y times P over YIP equal gamma I XIPI, right? So we divide YIP by XIPI. Volume share. Okay. So this is gamma one, right? We get the same? Is it identical to what we found in the definition? Yes, what report in the paper is 1 point for gamma one is 1.7. Oh, I should turn this off because hmm, okay, so you see the gamma report in paper. The first one is at 352.33, right? So the gamma one is 1.7 something. Okay. And what we obtain from our calculation is 1.7 something. Okay. One, which it should be, yeah, almost the same. This is gamma 2. Okay. Let's check this. Oh no, it's different. So it should be for this one, it should be 1 minus y1. Okay. Pressure. And this one should be 1 minus x. No, 1 minus x. Yes. Right. So to calculate gamma 2, we use y2, right? Y2 is 1 minus d7 in my Excel. Yes. Time pressure. Yes. Divided by XIPI. Okay. Divided by x2, right? P2. X2 is 1 minus C7. Okay. And P2, yeah, F7. All right. Hmm. But this one, it's why it's 0.9 something. Why is too large? Very large. No, this is too large. What's wrong with the calculation? Hmm. I think the pressure P2 is not correct for us. P1 is correct, but P2 is not correct, right? Because the pressure is too small. Hmm. Oh, oh no. EXP already. Hmm. Something wrong with this data. With gamma 2. I think gamma 2 is not correct.อืมการคำนวณเป็น1.71กว่าอ๋อมันปัดครับแต่ว่าแกมมา2ข้าวเป็นมันก็จะเพชเชอร์ประหลาดคือตัวนี้เป็นแค่ไม่ถูก correct that error first. อืมอะไรนะ
แกมมาสองP8 P2อ่ะ
ใช่ P2แปลกพวกมันมากเลยแปลกแกมมาเป็น9 กว่าซึ่งไม่น่าใช่
อันนี้พร้อมกับสูตร28แล้วก็เปลี่ยนตัวกัน
อืม
มันก็ได้
แต่แกมมา2เป็นไงเป็นร้อยกว่าเลยไม่น่าใช่อันนี้แหละเพชเชอร์เนี่ยมันน่าจะเป็น P2เพราะมันแค่0ค่ามันน้อยมากเลยเทียบกับอีกตัวหนึ่งเช็คเปอร์เฟกต์เป็นว่าเริ่มทำอะไรไปแล้ว The Excel which one Gamma this yes
เขาบอกว่า
ตัว equation อ่าที่เป็นปัญหาคือ MEK ใช่ไหมครับโอเค methyl ethyl ketone ถูกป่าวะ methyl ethyl ketone ป่ะ okay so we have different source of methyl ethyl ketone then try this one just one moment okay try this Armstrong equation Armstrong constant ABC เนี่ยฮะที่แชร์อยู่ใน this one should be A minus B over T plus C maybe อืม เมื่อกี้จบไปแล้วใช่ไหมฮะไปแชร์ไว้ให้ไหมฮะโอเคอือฮึเป็นไปได้มากกว่าอืมหาเจอไหมคำนวณไม่เป็นยังไงบ้างใกล้เคียงกับ
วิธีสมมตินะสมมติแบบในตัว ADP เนี่ย
อืม ตัว equation A เป็นไงบวก B หารด้วยบวกลบครับ A ลบ A ลบ B ส่วนใช่ใช่นี่ถ้ามันเขา Data ไหนมันเป็นตัวแต่ไม่ใช่ Data ที่มัน report ในนี้แน่เลยใช่ไหมเพราะว่าเราคำนวณแล้วมันคนละเรื่องเลย Okay, so anyway, we use that pressure. The pressure we calculate use Anton equation.
อาจารย์คะจอไม่ได้แชร์สกรีนค่ะ
อ๋ออยากให้แชร์อะไรอ่ะ อยากให้แชร์อะไรอ่ะแชร์ Excel
Excel ได้ค่ะอาจารย์
โอเคครับ so in this case we calculate gamma using different thing I think wow 1 moment 1.8 no ไม่ภาพเปลี่ยนความรู้ไม่ใช่แล้วที่สอง754แล้วทำไมที่นี่ถึง78เมื่อจะอะไรเดี๋ยวดูไม่ใช่เองทำไมการใช้เยอะอืม can so C2 is KP I7 what now it's gamma my gamma is 1.8 to 3 down to 3 so what is P2 you calculate it's R2 right A B C it's A the parameter for Anton equation is A is 6.18444 right and B is 129 oh no 1259.22 right and the last one is 221.758 right correct and we calculated from exponential e power to A, right? Minus B over T plus C. Yeah, it should be correct because the pressure is, well, 54 point something, right? Okay. Then down to well, we got 54 something, most of them. Yes, but gamma, your gamma, it's, why your gamma, it's what, only one? I think I got 1.8. Oh, okay. Y คือหนึ่งลบดีwhat is different? What is different? What is different? Different. That is why what we need y2. Oh, okay. Y2 is 1 minus y1 and times with concentration of 100 something. Okay. Okay. And divided by 1 minus x1 times p2. Okay. So anyway, I'm not sure about P2 because using the equation they given, well, we got different value. Okay. So we use different Armstrong equation here to calculate that this gamma. Okay. This is our gamma. But anyway, the trend is, yeah, this, what's it? The gamma is greater than 1. Okay. The trend is correct. Yeah. Gamma is greater than 1. So when we plot between insert, while we have to calculate log gamma first. Log gamma 1 and log of gamma 2. Okay. So this is log, right? Gamma 1. Yes. It's greater than 0. Okay. And we have, what is this? This is T. Okay. This is log of gamma 2. We use this gamma 2. Should be, yeah. Why? Okay, it's positive, right? So we plot between this x1 and gamma 1, log gamma 1. Okay. No. C and K. How to plot it? Plot C and K. No. Oh. Yes, and then we A problem plotting graph with Excel. Sorry. I use another software to plot. Okay. Hmm? Okay, so show you this. Okay, so we got this. Okay. I think this one is not correct. The gamma 2 is not correct. Because normally it will reach 0, right? Right? It should start from here. Okay. So this paper has critical problem on the data report. Yes. At this area, the gamma should approach, log gamma should approach 0. Right? This area, not from here. Should drive to approach 0. Okay? Where gamma approach to 1. So log gamma approach to 0. But for gamma one is correct. Gamma one, of course, it approach to one here, right? On this side. Only gamma two, it's not correct. Yeah, because the P, problem is P. So you have to find the reliable source of Angle equation. We need, yeah. Okay, so from this one, then we cannot check the thermodynamic consistency because we don't know the gamma 2. Gamma 2 here is not correct. So what else we can do? And okay, but at least you learn, okay, how to check the data. And yeah, let us move to next example then. Because this one, well, you cannot find P2, then it's, you cannot continue without Anton equation. Now let us move to this paper. This one was quite old. It's from 2001. This one reports the phase equilibrium system of hexene and benzene and hexene plus ethyl dimethyl ethyl ether plus benzene. Just one moment, it's ternary. Okay, all right. So we focus on binary first. For binary data, yes, table two reports the VLE, right? VLE equilibrium data of binary system of hexene, one hexene and benzene, okay? So again, even the paper, well, does not report the gamma, we can calculate by ourselves, okay? This binary system. So again, you use this temperature, xi, yi, right? Then of course you can calculate x2, y2, right? But in this case, they use the third component. They use 3, but it's binary system to represent benzene. Okay, so you can calculate x2, x3 and y3. And what else do you need? You need Anton equation because we need set Weber pressure at each temperature, right? So where is the Anton equation? Reported here. Which above? Down? Yeah, where is it? Oh, yeah, right. Anton equation. Yes, this is more simple. Shall we try again with this problem? Okay. Yeah, I'm going to give you now. Okay, you get it? You can do it by yourself. And from ABC first, and then calculate the P. So please do it, okay? And help me explain to others, because I'm not going to do it. You just check your file.
เป็นคอนเซ็ปต์สีนี่ก็ยังมากตรงครับใช่ให้เบต้า
ท่านกู้ไหมท่านกู้ไหมแกมาต่อไหมโอเค Okay, so just to make sure that you're working on the problem, okay?เราชื่ออะไรฮะรัชพลแชร์เลยฮะ yeah share your Excel share Excel อ่ะอือฮึข้อมูลบนทีนะฮะทีเดียวคุณกับอันนี้โจทย์ใหม่นะเจ็ดข้อมูล PDP 2เสร็จใช่ไหมแล้วกรอกอีกสองแบบอีกหนึ่งวันหนึ่งแบบอ๋ออันนี้คือที่เพื่อนกรอกโอเคนั้นเขาลอกมาเฉยๆเลย so we start from P1 P2 first right to check the pressure and then what then we copy the data x1 y1 or y1 from P P1 P2 which is calculated from Anton equation right and then you have x1 y1 you can calculate x2 y2 right x2 is 1 minus x1 and y2 also 1 minus y1 okay and once you obtain all these information you can calculate gamma 1 gamma 2 okay of course in the paper it's report already the gamma but the other use the same technique we use here If you use the same model and the same data, you always obtain the same gamma, and the same value of gamma. Yes. What? Oh, that's too large. Why is too large? No, it's just. No, the previous one, right? No, this is the new one. New power? Yes, but that one, your model is not that. Why you C1, C2? It's totally different. This one, because this one use Anton equation, not extended Anton equation. You need only 3 parameter, A, B, C. Yes. Yes, you see from that paper, it's required that A, B, C, right? So this is different. Which paper is it? Not this paper. You use that paper. That is the previous one. We move to new paper. Hiện nay vừa ra phát được nhiều lo chậm mát học cái chậm mát không chậm mát ok gặp cái bên họ ok ok được thôi biết này tức là so you obtain gamma already, right? Now plot between x1 and gamma 1 and also x1 and gamma 2. Plot in x-axis is x1 and for y-axis we plot gamma 1 and gamma 2. Now log gamma, plot between x1 and log gamma 1, x1 x1 and log gamma 2. Log là cái gì này? Cái gì là log. Measure log. And also, you look once you plot it, you look at the shape. You see that on one end, it approach gamma is 1, right? Approach to 1. Okay? Or if you plot log gamma, it must approach 0. Okay? Yeah, that means it's a little kind of. Gamma là nhiều, hiểuไหมแล้วถ้าเราปั๊บล็อกแกมมามันต้องโคสูงปั๊บเลยมันล็อกแกมมา Kind of what's wrong, right? Okay. ก็คือพัฒนาเด็กถ้าอย่างคุณคือก็ได้แต่หลักสูตรที่อันนี้ตัวของเราคิดแล้วกันอ๋อโอเคมันเป็นล็อกมันไม่ใช่แบบไม่ใช่ล็อกลองลอง I think the difficult part of the modeling is unit because there's so many units, right? Even pressure, the same pressure, but people use different units. The other thing is logarithm. Yeah, some formula use base 10, but some formula use base of natural log. So it's quite confusing. Yeah, มันเปิดแอปที่ได้เปิดแอปที่ได้ถ้ามันจะพอร์ตขนาดมันจะต้องมีมากกว่าแต่ว่าค่ามันเยอะมากแกนมากแล้วแกนมากเขาฝืนจะลองแล้วแกนมากเขาไม่แกนมากเลยแกนมากไม่เป็นครับนี่ต้องความรู้ของเราโอเคไปทำบุญกันมากเป็นแบบเวลาที่กับ Okay, so it should look like this, where two edges approach to zero, right? Log gamma must be zero. When this side has approach zero, or this side has approach zero. This one is not log gamma, but here you plot at log. Okay. Right? Log 1 must be 0. Once you take log, it becomes 0. So, for point-to-point test, we find the derivative at each point. The derivative at each point. ความช้าผมเช่นไรครับแต่ก็ต้องหาทั้งสองเพศที่แต่ละที You find the derivative. Okay, for example, this, let me write on this screen. It's okay. For example, this first point, you calculate this derivative and this derivative, okay? And then x1 times with the derivative of gamma 1 plus, let me share my slide. ไม่เป็นไรฮะจันโอเวอร์ไรด์ได้ Okay, this one. X1 comes with derivative of log gamma 1 plus x2 derivative of log gamma 2 at the same point. And it must be 0. Okay, so you calculate at each point, you calculate derivative of both two lines. Okay. Don't ask me how can we find the derivative. You draw a line there and then find the slope of that line. Okay. So you see how many data do we have? 10, maybe more. Okay, but anyway, each point must satisfy the given equation. Okay, must satisfy this given equation, and we call it point-to-point test because we test every point. Okay. I recommend you to do it by yourself again later, okay? And if you don't want to use point-to-point test because it's troublesome, because you have to draw a line and find the derivative of each point, right? You can use area test. For area test, instead of finding the derivative, you can calculate the area under the curve. Okay, so you see we have two lines, right? The first one is log gamma 1 and the second one is log gamma 2. Okay, you see this, the area under two curves we call A1 and A2, and summation of A1 and A2 must be 0. And we call it area test. Okay. Okay, well, you may have a question because log gamma, the area under the curve, both positive, right? And how can we obtain negative one? Because we have to sum all the area, right? but you look at the boundary of the integrand. The first one integrate from 0 to 1, and the other one integrate from 1 to 0. Okay, so you take the area and then multiply by it. Okay, so well, in other words, the summation is the area under the curve of log gamma 1 must be equal to the area under the curve of gamma 2, log gamma 2. Okay, don't know which one is easier for calculation. Okay, but it must satisfy this. Okay, you can use both point-to-point test and area test if you want. Yes, but normally once we obtain the data, we test with several techniques, maybe point-to-point test and area test, or radius test. After that, if you data fail to what's it? Fail in some algorithm, don't worry about that, because all algorithm is approximation, only approximation. Okay, maybe it fails some algorithm like point-to-point test or area test in past. Congratulations. Okay. Okay, so you can do it. You think you can do it by yourself? And the last one is no, not the last one. We have so many techniques. The other one is Reddish-Kister. For Reddish-Kister, instead of plot between log gamma 1 and x1, log gamma 2 and x1, we plot log gamma 1 by gamma 2. If ratio of gamma 1 gamma 2, you calculate or you already calculate log gamma, right? So just subtract log gamma 1 minus log gamma 2. The same thing, right? You calculate log gamma 1 minus log gamma 2 and then plot with x1. Try it. You will see what happens. Also share your screen because I don't work on that problem, so I cannot share anything now. Okay, share ได้เลย เป็นที่แช่ไหมอยู่So, well, for this test, we find the area above the x-axis and also the area under the x-axis. Okay? Both area we call a plus and a minus. Both area must be equal. Okay? Okay, good. So once you have good data, if your data pass these tests, okay? The next thing to do is okay, I take back my control. Okay, I will stop your chair. Okay, so for Reddish Kister, you you obtain a figure similar to this, right? Then you check the area here and area here must be equal. Okay. Then we call area consistency, and it's proof that your data is good enough for because it's satisfied with the give to him equation. Now we get back to the modeling part. One moment, sorry. No, I don't save it. Then what to do next? What we're going to do next? The next thing is we calculate the GE over RT because our aim now, because the data already passed the consistency test, right? The next thing to do is we're going to model the activity coefficient. Okay, call it activity coefficient model. And in order to do that, you need E over RT. How can we calculate how can we determine G over RT at each equilibrium? Of course, at different point, different equilibrium, different experiments, you obtain different G over RT. Okay? Using this equation. Here, for binary system. You see my screen, right? GE over RT can be calculated from XA log gamma A plus XB log gamma B. And you see that you already have XA, XB, log gamma A, log gamma B, right? You just sum everything up at each point, each equilibrium. Then you get GE over RT. Okay? You see that you calculate it, you get another column, which is GE over RT. And if you plot GE over RT with XA, you obtain this curve. But it's useless. You cannot use that kind of figure, that curve. What we're going to do is we divide GE over RT by XA, XB again, X1, X2 in our case. GE over RT divided by X1, X2. Here on the left hand side, GE over RT. We divide it by which one is 2. Okay? We get another column. Then we once if we plot G over T, xa, xb, x1, x2 in this case, with h1, the curve looks well close to linear. Okay. Now the curve looks linear, right? Then from this curve, if you approximate it by using one parameter, okay, you will get symmetrical model. Okay, symmetrical model. Like this one, A. This is really simple one because it's just a mean or average of each point, right? G over T is A3 of each point. You take average and then you obtain this parameter. Okay. But if you want 2 parameters, you can use Excel to find the trend line, okay? With 2 parameters, CXA plus BXB or A and B, whatever. Yes. We obtain Magru's equation, okay? Or if you plot, you find parameter in this form, A and B in the form of AB over AXB plus AXA. You fit your curve T over TXA3 with this model. Okay. Also 2 parameters, but the form of the activity coefficient model will be different. You get this, okay? We call it one-line equation. One-line equation. Okay, so I think well it's enough for today. Now you learn how to check the data. You know how to check the data and also how to model it. G over T, yeah, the curve like that. It's not linear. You calculate T already? Where is your T? Yes, I know. It's XA. You calculated already? Or I cannot see it from you. Which column you calculated? Oh, okay. I see. Yeah, it's okay. Any form, but it's not linear. Any form, but it's not linear. We can even add it. Any questions? Optimization. Okay. Okay, so we call it there, okay? Okay, finish.